Okay, let's kind of review metric conversions. Just kind of a brief overview of how to make metric conversions. A little bit of a reminder. First thing we need to remember is that metric measurements have two parts when we're looking at them. Two parts. They have a prefix, which tells us the magnitude of the element. Prefixes like milli, centi, mega, kilo, nano, pico, things like that. Those tell us the magnitude or the exponential factor of the measurement. And the second part of a measurement is the base unit. That tells us what we're measuring. If we're measuring in grams, we're measuring mass. If we're measuring in meters, we're measuring length. If we're measuring in meters cubed, we're measuring volume. If we're measuring in milliliters, we're measuring volume. So measurements have two parts, the prefix and the base unit. Prefix tells us what multiple of 10 or what exponential factor we're going to multiply by, and the base unit tells us what we are measuring. Just a brief review, the base units that we use are typically we see length, we see the meter, mass, we see the gram, time is measured typically in seconds, temperature is measured in Kelvin, though a lot of times in lab you will see it measured in Celsius because that's what our thermometers read, and amounts are measured in moles. All of these base units, except for Kelvin, can have prefixes, and prefixes tell us what's the magnitude of the measurement. For example, we know a kilogram is much larger than a milligram, okay? And these exponential factors are going to help us in our conversions. It's important to learn the symbols for the base units, the abbreviations, and the symbols for the prefixes, okay? Make sure you can distinguish between the capital letters and things like that. Micro has a little bit different symbol. This is a Greek letter mu, mu, Greek letter mu, and it's simply a U with a little teardrop on front or just a little line on the front of the U. Okay, so when we're working with metric conversions, because you know in chemistry we're dealing with a metric system, so how do we make these metric conversions? Well, we use dimensional analysis, which we've already talked about, and I have a previous video on dimensional analysis that you can watch, but we're going to use that same problem-solving method. In using dimensional analysis, we know we have to have a conversion factor, and our conversion factor is going to come from that prefix table on the previous slide that I just showed you. And that's something you really should commit to memory. Just kind of an aside, when setting up your conversion factor, remember your conversion factor is going to be a fraction. The prefix, the centi, milli, etc., is going to get a coefficient of 1, and the coefficient of the base unit is going to be the meaning of that prefix. For example, centi means 10 to the 2. So let's look at an example problem, and maybe that will kind of help us. First problem says, convert 402 grams to milligrams. Our given is grams. Our desired unit is milligrams. So we're going to have to go from grams to milligrams. Okay? Our conversion factor is going to come from this SI prefix table that's in your notes. And we have to look at the prefix that we're interested in. We are interested in milligrams. Now, this table says that milli is 10 to the negative third. It's a little difficult to see on this slide, but you have it in your notes, 10 to the negative third. So let's make an equivalency factor out of that. 1 milligram is equal to 10 to the negative third grams. When making these equivalency factors, the measurement with the prefix, or the number with the prefix, always gets a coefficient of 1. The meaning of the prefix, so milli means 10 to the negative third, is going to go beside your base unit. That makes these two numbers exactly equal. They make them exactly the same. So now let's set up our problem. When we're setting up our problem, we always start with what we know. Then we're going to set up a series of conversion factors, or a series of fractions that we're going to multiply by. Now, since we're starting with grams, grams is going to have to go on the bottom so that it will cancel out. Our desired unit of milligrams is going to go on the top. Grams will then cancel out, and we're left with milligrams. Now we're just going to put it in our calculator, and we're going to get 402,000 milligrams. Now, we need to check for significant figures. The first number has 3 significant figures. This is an exact conversion. Exact conversions do not count with significant figures. So your final answer must have 3 significant figures, in which it does. We could also report our answer to scientific notation if we wanted to. 4.02 times 10 to the 5th milligrams. Make sure you put your units. Alright, next one. Let's start with a prefix and go back to the base unit. Convert 4.2 centimeters to meters. 4.2 centimeters to meters. We are given centimeters. We are looking for meters. That's our desired unit. We now have to figure out our conversion factor. Okay, so we go back to this chart that we need to have memorized and look for our prefix. Our prefix is centi. Okay, so centi, lowercase c, means 10 to the negative 2. Okay, 10 to the negative 2. So our equivalency factor is 1 centimeter equals 10 to the negative 2 meters. The centi is a prefix. In metric conversions, your prefix always gets the 1, a coefficient of 1. The meaning of the prefix, 10 to the negative 2, is going to go by your base unit. That makes both of these sides equal. Okay? Now let's set up our dimensional analysis. We start off with what we know, 4.2 centimeters. And remember, dimensional analysis is a series of conversion factors multiplied by each other. So we set up our fraction, or our conversion factor. This is going to be our conversion factor. We're going to take this equivalency statement and set it up in a conversion factor. Since we're starting off with centimeters, centimeters has to go on the bottom so that it will divide out or cancel. Our desired unit is going to go to the top. Now remember, the prefix centi, any of these prefixes, mega, kilo, deci, centi, milli, micro, nano, pico, they always get a 1. Whatever that prefix's meaning is, or exponential factor is, goes by the base unit. Alright, so centimeters will now cancel. We're left with meters, and all we do is put it in our calculator. When we put it in our calculator will say 0.042 meters. The last thing that we need to do is check for significant figures. We start off with 2 significant figures, and since this is a conversion factor, we do not count it in significant figures. Our final answer has 2 significant figures. Now, let's try one last problem. We have a little bit different problem here. It says convert 4.2 centimeters to micrometers. Well, that starts with a prefix and goes to another prefix. Well, how are we going to do that? Well, in metric conversions, we need to always go back to our base unit. So this one's going to have an extra step because we're going to go from centimeters to meters, from meters to micrometers. Okay? So we're given centimeters. We're looking, or our desired unit is micrometers. We're going to get our conversion factor from this SI prefix table that you need to have memorized. And instead of just one equivalency factor and one conversion factor on this one, we're going to have 2. We need to have centi and micro. Okay? So the equivalency factors are going to look like this. 1 centimeter, remember, when making metric conversions, the unit with the prefix always gets a coefficient of 1. The base unit that's in that equivalency factor gets a coefficient of the equivalency factor, or the exponential factor, of the meaning of the prefix. Okay, so centi means 10 to the negative 2 meters. The other conversion factor that we're going to have, we have 1 micrometer. Remember, micro is a prefix, so it gets a coefficient of 1, is equal to 10 to the negative 3rd meters. Okay, so let's set up our dimensional analysis. We always start with what we know, 4.2 centimeters. Then remember, we have to set up a series of fractions to multiply by. Since centimeter is in the beginning, it has to go on the bottom of the next conversion factor so that it will cancel. Okay. Then the other part of your conversion factor, the 10 to the negative 2 meters, is going to go on top. Now this is important. We always have to go back to the base unit if we're going from one prefix to another prefix. We always have to go through the base. Centimeters will cancel. We're left with meters. Well, can we stop? No, not yet, because the question asked us for micrometers. So now we've got to go from meters to micrometers. Okay? Since meters now is on top, meters has to go on bottom. So this is a little bit different. Same concept, but make sure you get your exponential factor on bottom. Whenever you're lining up dimensions or whenever you're lining up units, they have to be opposite each other in order to cancel. And we get that 10 to the negative third from the micrometers that we're going to. Okay? We're taking these equivalency factors and turning those into conversion factors. All right, meters will cancel. We now put that in our calculator, and our calculator tells us 42,000 micrometers. We've got two significant figures in our starting factor. Exact conversions do not count, so we have two significant figures in our final answer. And that wraps up metric conversion review.